Okay, we are going to look at how to find probabilities, how to find z-score probabilities using the standard normal table. Okay, so we can call this maybe finding z-score probabilities. And there are actually 3 cases here. That we're going to look at. The first case is a less than probability. The second case is a greater than probability. And the third case is a between probability. Okay, and just a quick review. A less than sign looks like this, and a greater than sign looks like that. And the way to remember this is you can think of a less than sign. This is kind of like the head of an arrow pointing to the negative side of the number line. Okay, negative direction, this is the positive direction. So the greater than sign is an arrow pointing in the positive direction. Okay, so now, and then I'll show you how we'll write between when we get there here. So the first case here, which is a less than probability, this is the simplest of the 3 cases. Okay, so let me just do an example, and then I'll write a rule out. Okay, so maybe for our example, I'll do the probability that z is less than, I'll just say positive 1.85, let's say. Okay, so to do these, I would draw a curve to give you a nice picture of what's going on. You would put 0 in the center. Okay, now 1.85, that is a positive z-score, and so I'm going to put it on this side of 0. This is the positive side. And 1.85, okay, that's well beyond 1 standard deviation, but it's not like all the way out here on the edge. So, I don't know, maybe like that. That's maybe not perfect. This doesn't have to be perfect. I would just make it realistic. So there's 1.85. And then what I want is I want this area that's less than that. Okay, so I'm shading the area to the left of this. One way to know what side to shade, because you're either going to shade all the area below or above. One way of knowing which way to shade is this less than sign is like an arrowhead pointing that direction. So I'm going to shade that side of 1.85. That makes it kind of easy to remember. So this is all the area less than that. So now all I need to do is look it up. So get my normal table. I'm going to go on the positive side over here, and I'm going to look up 1.8, 0.05, and where these overlap, that gives me the area that I'm looking for, 0.9678. So this is 0.9678. Okay, and so that's actually the area I'm looking for, because I want all the area to the left of this z-score, and the table gives me the area to the left. So the table gives me the area I want, 0.9678. So that is the probability. Okay, you could also think of that as a percentage. 96.78% of the population have z-scores below 1.85. Okay, so the rule for this would be something like this. Look up z-score on table, and then the area on table is the desired probability. Okay, and that's the easiest case. You just look it up, and the area on the table is your desired probability. So that's case 1. Okay, so case 2 would be the greater than probability. Okay, and so an example might be something like z, we'll say greater than, we'll say positive 0. Let's say 65. Okay, and so that's a greater than sign. It's pointing that direction. Okay, so let's draw a picture. 0 goes in the center there. This is still a positive z-score, so it's on this side of 0. Okay, but it's a little closer to 0 now because it's not as far out in the end. It's maybe about there. That's doesn't have to be perfect, but that's about where it is. And notice I want the area above that. Okay, that's a greater than sign, and that's like an arrow pointing this direction. So I'm going to shade that side. Okay, so I'm wanting this area here. Now when I look up that z-score, it'll give me the area to the left of, because the table always gives me that area. Okay, and that's okay, I'll get that area, and then I can find this area. And we kind of saw in the last video that this area is just 1 minus that area, because the two areas add up to 1, right? So it's a complementary probability. Okay, so I'm going to look this up on the table. I'm going to get this area, and I'll write that out. I'll label that here. So on the positive side, I look up 0.6, 0.05, where these intersect. I get 0.7422. And so that's this area, 0.7422. Okay, so that's all that area. Not what I want, but of course with that I can get the area above by just subtracting from 1. So I take 1 minus 0.7422, which will be 1 minus 0.7422. I get 0.2578. And that is my desired probability. Okay? So again, if you remember, the total area under the curve is 1. Okay, the area below it is this, the area above it is that. If you add the two together, they would equal 1. So if the table gives me this area, to get the area above it, I just subtract that area from 1, and I get the area there above it. Okay, it's basically the complement rule from chapter 4. So if I were to write a rule for this one, then it would be probably something like this. Look up z-score on the table, and then maybe the desired probability is 1 minus the area on the table. Okay, so you look up the z-score on the table to get this, and then the desired probability is 1 minus that. Okay, and so that is the second case, greater than probability. So the first case, let's just quick review here. The first case, oh, no, not it. First case is the less than probability, and all you do is look it up on the table and get your area. The second case is the greater than probability up here, and whenever it's greater than, that's when you have to subtract from 1. You look it up on the table, subtract from 1. Okay, so the third case now. Case 3. This is, case 3 will be the between probability. Okay, so by this I mean something that would be like this. Maybe the probability that z is between, I don't know, we'll say negative 2.35 and 0.97, let's say. Okay, so the way you write between here is you have two less than signs. I put z between these two z-scores, and I have this less than sign. Okay, so don't try to figure out like this is less than z is less than that. That gets confusing to try to figure that out. Just say, if I want to say between, I do the lower one on the left, put a less than sign, put z, put a less than sign, put the upper one. And that's how you write between. Okay, so now I'm going to put 0 there. This is a negative z-score, so it's over here now, and it's pretty far out here, negative 2.35, and this z-score here is positive, and so it is 0.97. And now that's going to be a little closer to 0 that time. So it doesn't have to be perfect, just make it realistic. And so I want this area between the two. Okay? So what I'm going to do is I'm going to look up this z-score over here, and that's going to give me all the area from that z-score all the way down. Okay? And that's too much area. I don't want to go all the way down. I actually want to stop when I get to here. I'm going to go from here to here to get the area between those two z-scores. So what I'm going to do is I'm going to then look at the area up below this z-score, and I'm going to be able to subtract the two areas to get the area in the middle. Okay, so let's look at it. On the positive side, I look up 0.97, and I get 0.8340. So 0.8340, and then I look up negative 2.35 on the negative side, so negative 2.35, and I get 0.0094. So this one is 0.0094. Okay. So to get the area between, this gives me all of the area. I want to take away this area, and then that leaves me with the area that's between the two. So I take the 0.8340, and then I subtract 0.0094, and that is going to give me the area between them. 0.8340 minus 0.0094, and I get 0.8246, and that would be this desired probability. Okay, so if I were to write a rule for this, whenever you do a between one, you look up both z-scores, and then you're going to take the large area minus the small area, and that's going to give you the area between the two. So let's write that rule out. We'll say look up both z-scores, the desired probability is large area minus small area. So you look up both z-scores, you take the large area, which will always be the one on the right side, the one further up, and subtract the area for the other z-score, which is the smaller one. So you subtract those two, you get the area between, and that's how you get the area between two z-scores. So I left a little space over here. I want to show you one more example. And what that is here is I'm going to find the area between -1 and 1. So I want to find this area. Now if you remember that empirical rule, this was 68%, right? So you would expect this to be like 68%. So let's see what happens when I look it up on the table. Okay, so if I look up on the positive side, 1.00, I get 0.8413. Okay, and then when I look up below the -1, -1.00, I get 0.1587. Okay, so now I'm going to subtract these two. 0.8413 minus 0.1587, and let's see, that gives me 0.8413 minus 0.1587, and that's where I get the 0.6826, and that's the decimal form here. If I changed it to a percentage, it'd be 68.26%, and so the 68% is just rounding to the nearest percentage. So that's actually where you could do the same thing. That's where the empirical rule comes from. You could do between -2 and 2 and -3 and 3, and you would get those percentages. And they would hold for any normal distribution. Okay, so just a quick review then. You have the three cases, right? A less than probability, you're just looking up the z-score, and the area on the table is the desired probability. For a greater than probability, you got to look up the z-score, you're going to get the area below it, so to get the area above it, you subtract from 1. If you're going to do a between probability, you got to look up both z-scores, and then you take the two areas and subtract them to get the area between. And that is finding z-score probabilities. So in the next video, we are going to learn how to use the z-score table backwards.